Well, good evening. I'm Bill Roach, and I'm the chair of the Environment Committee, and we're really pleased tonight to have a very distinguished author and professor of Earth Sciences and Space, I believe, from the University of Washington. He's been here, came there out of graduate school in 1991 and never left. Thought this was too nice a place to leave. And he also has a man of many talents. He has his own band called the Dirt Band, and they have a gig coming up on the 4th of February in Fremont. So, but that's another story. So I'd like to introduce you to Dr. David Montgomery.
Thank you, Bill. And thank you for inviting me back here. I've forgotten how many years ago it was when I was last here, and even which book I was talking about then, but it was probably one of the books about soil. And you know, the 4 books that my wife and I have written about soil are up on the screen now, and what I'm going to try and do tonight is tell you mostly about the new book, What Your Food Ate. But it's part of a series of books that started with thinking about the role of how the way people treat the land affects the future of their descendants on the land. I'm a geologist by background and training, and as part of that, I'm the kind of geologist who studies the here and now of geology, how erosion shapes the land, what's called geomorphology in the earth sciences. And to study that, you study erosion, how sediment moves from one place to another, because that's how nature shapes topography. So one of the first books that I wrote for a popular audience was Dirt, the Erosion of Civilizations. When I started writing it, I thought I was writing a history of how erosion how people had interacted with erosion through history. And what I ended up writing was a history of farming. It was not what I thought I was going to be writing about, but that's what the story was in terms of how people have treated their land. And the short description of that book is that societies that abuse their soil don't last. That soil erosion can limit the lifespan of human societies. That got me intrigued as intellectually as a geologist, and I started looking further into things. When Ann and I wrote The Hidden Half of Nature, the second book in this series, it was looking at what is the natural basis for soil fertility. And it opened our minds to the world of microbial life, all the bacteria and the fungi in the soil that are doing a lot of the heavy lifting of ecosystem processing and turning dead stuff back into the next generation of living things that really fueled the restoration of soil in our yard. And I'll tell you a little bit about it as I go through the most recent book. But Growing a Revolution is a book that I wrote looking into how the lessons and the science about how important microbial ecology is, and soil ecology in particular, to the practice of farming, how we can take those lessons and apply them to solve the problem I wrote about in Dirt, and that farmers can do it at scale on farms around the world. That's what I wrote about in Growing a Revolution. It's a look into what's now called regenerative agriculture, an agriculture that can rebuild the fertility of the land as a consequence of intensive farming that grows a lot of food. What Your Food Ate is the book that Ann and I wanted to write. After we got through all the research and the heavy lifting and the dot connecting and those other books, we were left with the question of, okay, so farming has destroyed a lot of land in the past, but farming, if done right, can fix land for the future. But what does it mean for what's in our food? What's the connection between the health of the land, soil health, and our health individually, and our health as societies, public health? That's what we wrote about in What Your Food Ate. And to make a long story short, soil health is our health. The way that we treat the land does reverberate back up into our own health. How do you connect all those dots, going from the soil to plants to animals and all the way to us? Well, that's what we tried to do in What Your Food Ate. We had to dive into a lot of different disciplines to try and look at the connections. But if you do, and you break it down, you can go all the way on little steps that are supported by a lot of peer-reviewed research in scientific journals to connect that says that the health of the soil influences the health of the people that actually live on the land. And so how is that? Well, what I want to do with this talk is sort of walk you through the whole circle of thinking about how our farming practices affect the health of the soil, and then we'll go over to look at the far right about how that affects the health of our crops, health of our livestock, and our health. We'll divide it up into those 4 sections and sort of go one at a time So let's start with the health of, or the current state of soils globally. Most of the credible evaluations of how much land has been lost to soil erosion and degradation globally since the dawn of agriculture land on answers of somewhere between about a quarter and a third of the world's potentially arable, potentially farmable land has been taken out of production because the soil and the land are degraded so far. That's the story that I wrote about in Dirt. That's a lot about the past. About the present, the UN's Global State of the Soil Assessment from back in 2015 concluded that us, the global us, humanity, is losing about 1/3% of our global food production capacity each and every year to ongoing soil loss and soil degradation. Now, that 1/3% is not very much in any one year, right? But if you think like a geologist and play that out over the next century, that 1/3% turns into almost a third, another quarter to a third of our ability to feed ourselves is at risk with agriculture the way we're doing it today, according to the UN's assessment, which is actually kind of a pretty middle-of-the-road assessment. Those two things added together, the historical degradation of land and the ongoing projections, suggest that unless we shift our agricultural juggernaut, unless we change the way that we farm, we're on course to actually have degraded our ability to feed people on this planet by about half, while our population is still projected to rise by another third by the time it peaks somewhere later this century. That's obviously not good planetary stewardship. Well, so what has actually happened to degrade farmland around the world? Well, the thing that really surprised me in researching the Dirt book was that you can point the finger pretty solidly on the degradation of land in many ancient societies around the world at the plow. That most iconic of agricultural implements. I mean, when you think about what farmers do, or if you listen to country radio, as sometimes I have to do when I'm giving talks at farming conferences, that's what farmers do, right? They plow. And there's reasons they do. I could go into all that. But the thing that is relevant from a geological perspective is the plow leaves the soil vulnerable to erosion. Why? Because it inverts it. Nature tends to clothe herself in plants, and that helps to keep the soil on the land. It actually adds organic matter and fertility to the land as well. And a freshly plowed field, when it rains, behaves a lot like a construction site that, living in an urban environment, you've probably seen construction sites where when it rains, what color is the runoff that comes off any bare soil? It's brown. It's carrying the soil away. Farms are no different when they're freshly plowed. And the story I put together in Dirt looked at how that had affected societies and the fertility of the land around the world time and time again. And so we have had this problem that soil erosion and degradation have been racing ahead of rebuilding soil at the paces that are shown on this slide now. One of the things I did in writing the Dirt book is I took advantage of being a professor at UW, and I went to the library for about a month while my students were in the field. And I was trying to collect information on, is this idea that farming could have limited the lifespan of civilizations, is that actually holding water? So I basically vacuumed up all the data I could find on how fast are the world's farms eroding today. And there's an awful lot of data out there in journals if you'd spend the time to pull it together. And what I came up with is the average rate of erosion on a farm around the world today is about an inch of soil being lost in every 20 years. Now, that's less than a millimeter a year, right? Your fingernails grow faster than that. It's not a screamingly fast pace unless you're thinking about long periods of time and you're thinking about how fast it takes nature to rebuild soil, and nature builds soils slowly. I also compiled data on how fast does nature build soils, and it takes nature about 500 to 1,000 years to replace that inch of soil that we can lose with a couple decades of conventional farming. And if you don't believe those numbers, you can drive around the Midwest and look at the pioneer cemeteries. They all sit about a foot or 2 or 3 feet above the surrounding cornfields. Why? Because they've been losing soil at about a millimeter a year. And one of my students basically documented that across the entire corn belt of the U.S., where about 50% of the soil has been lost in the last 100 years alone. So therein lies the problem with a lot of our basic style of agriculture. We've been losing soil faster than than nature can replace it. And it's not just the problem of actually the physical loss of the soil itself. It's also a problem of the loss of soil organic matter. There's a paper in the journal Sustainability that's up on the screen now, a few years back, that concluded that the soil organic matter content of the agricultural soils across North America is only about half of what they were when they were first plowed or first converted from forests or prairies into agricultural fields. Now, what does that look like? It looks like the difference between these two soils. This is actually from North Carolina, where the story is very similar. And in fact, those numbers of 50% soil organic matter loss for around the world are pretty robust for places that have been farmed conventionally for a century or so. So how many of you would rather, as a farmer, be farming that khaki stuff on the far side rather than the brown stuff? Nobody. Gordon's giving it a big thumbs down. I'd give it a big thumbs down. I've yet to find a farmer who wants to farm the khaki stuff. These are soils that were literally collected across the fence from each other. What's the difference? The khaki one on the right was collected off of a modern tobacco field that's been conventionally farmed using lots of tillage and agrochemicals for 100 years. The one on the left was a neighboring farm that was abandoned in the 19th century. And the soil has basically rebuilt its organic matter. The color difference you see between those two, that's carbon. Soil organic matter is about 40 to 50% carbon. And what's basically happened is that in our conventional farming practices, we've basically degraded the soil organic matter, which turns out to be the food that feeds microbes that drive a lot of the processes that get things like minerals into our crops. We've basically degraded it substantially so that we now have to use a lot of chemical fertilizers to produce the same kind of harvest that you could get if you had healthy soils that were more like the native soils. So we've converted healthy, fertile soils into essentially dirt through our farming practices, and we're not the first society to have done that. But the Romans didn't have nitrogen fertilizers; they had pigeon poop, but that's a whole other thing in a chapter, and a whole different level of impact. But we can degrade soils faster than people did in the past when they were only armed with the plow, because now we have mechanized plows and a lot of agrochemicals. So what are the problems with modern farming in terms of soil degradation? Well, I can really point to two primary things. There's the heavy use of routine tillage, plowing everything up and leaving it bare and vulnerable to erosion. Imagine what would happen on this California farm if it rained on that freshly plowed field. You're going to lose some of that soil, and it would take probably a century to replace it. And the overuse of synthetic nitrogen fertilizers. I'll get into a little more about why that is, that they affect soil fertility, but the problem remains the same. Now, I promise you, that kind of concludes the depressing part of this talk, because what I want to focus on is the question of, can we actually reverse the historical pattern of soil loss and soil degradation? And if so, how fast could we do it? This is the question that I was essentially left with after writing Dirt. And I'm happy to say that I think the answers are yes, and pretty darn fast, like shockingly fast to a geologist, in fact. Why am I confident of that? Well, my wife and I bought a house north of here when I got tenure at UW, and it came with soil that was a lot like this khaki stuff on the left. She's a biologist. She really wanted a garden, and when we lived in graduate student housing and apartments, we didn't have any space. We finally buy a house. It has a side yard. We slick off the lawn. What do we find underneath it? Dirt. It wasn't good soil. There wasn't a single worm that crawled out of this khaki organic matter-free soil that we had. So Anne started thinking, well, we've got the geology part of soil. What we don't have is the biology. So she started what we called her organic matter crusade that we wrote about in The Hidden Half of Nature. And she started composting and mulching and getting all the sources of organic matter that she could find and returning them to the yard, just layering them on the ground. And she would put out organic matter in the spring, it would be gone by the fall. So she put more out in the fall, it would be gone by the spring. And we knew that it wasn't just disappearing. It was the biology in the soil that was eating it, taking it down, mixing it up into the soil. Over the course of about 10 years, she turned that khaki stuff on the left into that dark black stuff on the right. This is the same soil from our yard. The stuff on the left is from the area that she didn't garden. We just left it the way it was. It was behind the garage. Nobody looked at it. We didn't care. But it was the same as the stuff. Well, it was the same basic soil. But the one on the right has 10 years worth of her organic matter crusade and change. And that started to motivate us to think about, well, could you do this on farms around the world? And that's what I wrote about in Growing a Revolution, was looking at farmers like Gabe Brown, he's a farmer from Bismarck, North Dakota. His hands are here showing his soil in his right hand, the elevated one, and his neighbor's soil in the left one. What's the difference between these two farmers? Well, one of them's been rebuilding the soil organic matter using practices that really paralleled what Ann did in our yard. And that I'll get to in a minute, but I just want to show you the magnitude of the effects where you can reverse within years the effects of degradation on the soil by simply changing one's practices. These two soils are from Singing Frog's farm. It's a farm, I encourage you to Google it. It's an amazing little farm down in Sebastopol, California, in wine country, where Paul and Elizabeth Kaiser started a no-till vegetable farm that's only about 2 acres in size, but they harvest a couple $100,000 worth of vegetables off it every year. Why? Because they've turned the soil they started with, that crappy stuff on the left, into the soil they now have on the right. And they did it with regenerative farming techniques that I'll talk about the commonalities of in a moment. But the point is that these are the same soil in the sense that if you looked on a government soils map, they would look identical because they're in the same neighborhood, literally just across the fence from each other. The difference is how people have treated the soil, in this case for about a decade. So what were the commonalities between Ann's gardening practices that rebuilt the fertility of our yard and the practices of these farmers I visited around the world, like the Kaisers and Gabe Brown that I wrote about in Growing a Revolution? It's that they all practiced regenerative farming or gardening practices. And what does that mean? What were the commonalities? Minimal disturbance of the soil. So they were not plowing. Ann was not double digging her garden beds. She was just layering stuff on the surface and letting the organic matter accumulate and get consumed by soil life. It was always keeping the soil covered. In a farming context, this can mean with cover crops so that you don't have bare earth. You're always having a living plant in the soil. And there was diversity to the crop rotations on the farmer's fields. In Ann's case, it was diversity on her vegetable beds and diversity, diverse plantings in her planting beds. Many of the farmers are also reintegrating animal husbandry into their operations, and I had been trained to think that animals, and cows in particular, were environmentally destructive. And what I learned in writing Growing a Revolution and further in What Your Food Ate was to actually see that it's not so much the cows themselves, it's how we raise them and how we feed them that actually have the negative impacts on the environment. And those and that animal agriculture can actually accelerate soil building processes and enhance the fertility of the land if done right. I should note that why did this suite of practices work? Well, think about it through the lens of soil life. Minimal disturbances, providing them a stable habitat. What would happen if about once a year somebody came and took the roof off this building and stirred the contents up with a giant spoon? You wouldn't be happy about it, would you? You'd probably move. Soil life, that's what a plow does to the soil, right? If you minimize disturbance, that provides stable habitat. If you keep the soil covered with living plants, that's providing a source of organic matter. That becomes food for the microbes. So you got shelter, you got food. What else do you need? Well, community. A diverse community. Diverse crop rotations actually lead to diverse communities of life in the soil. And think about what is it that makes humanity so competitive in biology? The way we organize, not as individuals but as groups, has actually had a huge effect on things. And we can each specialize in something. I can be a geologist. You each had your own careers. That allows us to do more things together. Soil life is similar. The community structure really matters. And these three principles at the top, above the animal one, also happen to be just about the exact opposite of what we've taught in agriculture for about 100 years, where we've taught intensive tillage, reliance on nitrogen fertilizers for fertility, and specializing in growing 1 or 2 crops on a farm. This is the opposite of what it would take to build healthy soils. But what are the benefits of building healthy soils? It's not just to make the soil dark. It does put some carbon in the ground. But some of the benefits of healthy soils are that the regenerative farmers that I visited around the world were able to harvest comparable amounts of food to their conventional neighbors, but they would do it with using less fertilizer, less pesticide, and much less fossil fuel. And what do I mean by less? Like 50 to 90% less. 50% less on the diesel, because if they go no-till and they stop plowing, they drive half as frequently across their fields. But they could cut their fertilizer and pesticide use by up to 90%. Why? Well, we'll get into that, but it all relates to how the health of the soil translates up into the health of the crops. The color differences you saw in all those slides of soils, that's carbon. Rebuilding healthy, fertile soil takes carbon out of the atmosphere through photosynthesis, and it puts it in the soil where it can actually form the basis for fertility. Now, it doesn't stay there forever, obviously, but you can think of the soil as a reservoir for carbon that's been depleted over the agricultural era that we could refill if we change the way we do agriculture. But the part that is actually making all this catch on so far in the ideas of regenerative farming in farming communities is that it's actually more profitable for farmers. Why? Because they're spending less on agrochemical inputs, but they're harvesting the same comparable harvests after they get through a couple-year transition. What that means is that their bottom line is better. They can keep more on the farm. So soil health, the way we farm actually translates into differences in soil health as visualized by differences in soil carbon, the colors of those soils. But what does it mean? What does soil health mean to plants? Well, this is where we get into how it is that it worked to basically have adding organic matter to the soil rebuild the fertility of the soil, in that there's what Ann and I came to call a biological bazaar in the soil. I like to call it the original underground economy, but Ann hates that because it's too bad a pun. So what's happening is that you have these plants. There's a zone around the roots of a plant called the rhizosphere, which is literally Greek for zone around the roots of a plant. And it's an area where the action is happening that we weren't actually taught in graduate school. We know that plants will take carbon dioxide from the atmosphere, water up from their roots, combine that to make carbohydrates to build their bodies, and the food that we can then eat, or the food that our food eats. But what we weren't taught is that roots also exude compounds into the soil. Roots aren't a one-way street. We were taught they were straws. Most of us probably think of them as straws, how plants get the stuff they need out of the soil. But they also exude compounds into the soil, and those exudates are things like carbohydrates, fats, and proteins. What does that sound like? It sounds a lot like food, doesn't it? Why are plants dripping food into the soil? How many of you actually, would take, and plants can exude into the soil, up to a third or more of what they capture through photosynthesis, they can push out of their roots into the soil. How many of you would spend up to a third of your income by just going out and leaving it on a street corner somewhere? I've yet to meet anybody who does that. But we all pay taxes, right? Why do we do that? Because we expect things to be done with it. Certain basic services, for example. That's what plants are doing. They've outsourced some of their basic survival functions by feeding the life in the soil that congregates around their roots, consumes those root exudates before they get anywhere. On average, root exudates travel about 1 millimeter to 1 centimeter away from the root before something eats it. That's where the magic happens. Because what does any organism do with what they eat? They metabolize it, right? And they excrete their waste products. When we found out that plants were releasing exudates into the soil, microbes were consuming those exudates, and those microbes made compounds that benefited the health of the plant. Things like plant growth promoting hormones that promoted the growth of bigger plants that could grab more solar energy, that could share some more of it with the life in the soil. It's a positive, mutually beneficial relationship through which the plants are feeding life in the soil, and the life in the soil is supporting the health and vibrancy of the plants. And fungi in the soil can essentially link up with the plants and send their little root-like hyphae out into the soil, where they will mine things like phosphorus or nitrogen, things we know in agriculture today as fertilizers. These fungi will specialize in grabbing them and bringing them back and sharing it with the plant. Why? Because the plant is giving them sugar, and everybody loves sugar. What difference does this make to agriculture? Well, it means we can think about plants as having two very different diets. There's in conventional agriculture what Ann and I call the fertilizer diet, where we know that you can grow high yields of crops even in very degraded soil if you add enough N, P, and K, nitrogen, phosphorus, or potassium, the big three you'll find on any fertilizer label. We know that you can get high yields, you can grow lots of biomass that way, but what do the plants lose out on? Well, in plants that are fed a lot of the three elements they need for big, robust growth, don't tend to invest in the root systems. So if they don't have much in the way of a root system, they're not putting out much in the way of exudates, they're not building healthy soils, they're not recruiting life in the soil, and they're basically missing out on the micronutrients that the microbes provide, and they're missing out on the beneficial metabolites that the microbes provide. In other words, they can grow big, but they're being shortchanged on what they need to stay healthy. If we think about the soil health diet, on the other hand, if you're growing plants in healthy, fertile soils, they'll put out a lot of exudates, they'll recruit a lot of microbial life because they get a return on it. If there's nobody living in the soil, a plant that puts out exudates really is just burning their money. If they're growing in healthy, fertile soils, you don't need to add much nitrogen, potassium, or phosphorus. In fact, there's studies out of Virginia that show that the optimal amount of nitrogen fertilizer to use on healthy, fertile soils is 0. But if you don't have healthy, fertile soils, well, you get a big return for adding more nitrogen. But plants grown in healthy, fertile soils will get more beneficial micronutrients and more microbial metabolites, things that promote crop health. And it's no coincidence, we argue, that the global sales of pesticides went through the roof after the global sales of nitrogen fertilizers in the 1940s. You can kind of look at the sequence, and we went to mechanized tillage and then nitrogen fertilizers. All of a sudden, pest problems went through the roof. And you know where you would go if you wanted to find farms that have the fewest agricultural pests on them today? You go to organic farms that are not using nitrogen or pesticides. And that's completely counterintuitive when you think about the abundance of pests. And why is that? Well, broad spectrum pesticides take out both the pests and the predators that eat the pests. And if you're familiar with those sort of old, Ecology 101 kind of textbooks of looking at like the deer and the wolves arriving on an island, if the deer arrive first and then the wolves come, the wolves eat half the deer, and they both crash, who comes back first? It's not the predators. The prey have to come back first before the prey will come back, before the predators will come back. That's basically the system we've institutionalized on our farming fields. So why is the provisioning of mineral micronutrients so important, or the role of microbial life in providing micronutrients to plants so important? Is because there are elements that we need a little of, micronutrients, but we need that little of an awful lot. Things like iron and zinc or copper. I mean, how many of you have ever eaten pennies to get your daily dose of copper? It doesn't work very well. You need that copper to be integrated into biomass, but you need it to be there. And how do the plants get it? Through those interactions with soil life. So micronutrients getting into our food is mediated by soil life. Things called phytochemicals are also mediated by soil life. And what are phytochemicals? Well, phytochemicals, the word means, phyto is plant, chemicals, chemical, so they're plant-made chemicals. Things like the linalool in lavender that gives it its distinctive smell, or the sulforaphane in the brassicas, like broccoli and cauliflower, that has anti-cancer properties when it makes it into our bodies. Or the curcumin, the active ingredient in turmeric, that similarly has anti-cancer properties. These are chemicals that plants make in response to interactions, for the most part, with life in the soil. Now, why are plants making phytochemicals? They're not making them to prevent cancer in us. They're doing it for their own business. They're doing it because it's their means of communication. Plants are stuck in place, right? They can't get up and run away from a predator or an herbivore. So they've developed chemical signaling adaptations that actually provide communication between plants, but also between plants and life in the soil. Phytochemicals many of them are defensive compounds. And some are for protection from things like ultraviolet radiation, the beta carotene in carrots, for example. You'll find that as an ingredient on many sunscreens because it's great UV protection. So plants are making all kinds of chemicals, many of them in response to environmental stimuli and life in the soil for defense, communication, and protection purposes. And those phytochemicals, it turns out, really are nature's health plan for maintaining healthy plants. And that translates over to our crops. But what happens when you grow plants in nitrogen-rich environments with degraded soils? They don't make anywhere near as many phytochemicals, orders of magnitude lower in cases that have been documented. So the interaction with life in the soil is important for maintaining the health of crops. So we've got how we farm can affect the health of the soil. The health of the soil affects the health of our plants and our crops. And so one can fairly ask the question of, well, what difference then does soil health make to the composition of things we grow on our farms? So Ann and I did a study that involved 10 paired farms around the United States, where we took one regenerative farm that followed that no-till, cover crops, and diversity regimen that I talked about earlier, and had them grow the same crop in the same soil type as their neighbors across the fence who were conventional farmers. And then we tested the mineral and vitamin and phytochemical content of the crops that were grown in those fields, and we tested the health of their soil. And this slide shows you the results from the comparison. The map shows you where the farms were across the U.S., but in terms of the organic matter content of the soils, the regenerative farms had roughly twice the organic matter in their topsoil as the conventional farms. And that translates into roughly twice the amount of carbon as well, if you want to do carbon accounting on farms. In terms of soil health scores, the regenerative ones had roughly 3 times higher. Why the difference there? Because it's life in the soil that helps, that is also a factor in a soil health score. So there's pretty solid evidence that the way that we farm can influence soil health. What about what was in those crops? Well, this is a summary of what we found on that study, which was a very limited study. So we included the word preliminary in the title because this is not a huge data set. But we did find that the phytochemical levels were 15 to 20% higher. The micronutrient levels were 15 to 30% higher, and the soil health scores, as I mentioned before, were up to a couple times higher. But so there seems to be some pretty good evidence that differences in the way that we farm translate across into the health of our crops, the health of our soils, and what's getting into our food. And I'll talk a little bit more in a few minutes about what difference that might make for our health. In the meantime, we'll move down to the lower part of the circle around the soil health circle to think about, okay, well, how does all this translate into thinking about the health of our livestock and animals? So what we've looked at so far is the first of what Ann and I call the Fab Four of the 4 things that farming practices and soil health really affect in our diet. The first is micronutrients. Regenerative farming practices, it seems, result in higher levels of them. The others are looking at the fat balance in animals, level of phytochemicals, and also the level of microbial metabolites in our food. So let's move into the animal world. So when we think about the cow, if think about it as another biological bazaar, because the rumen, it's, we tend to think of maybe a rumen as a cow's stomach, and that's totally wrong. A rumen is like a giant fermentation tank in which microbial activity is taking that grass that the cow is chewing and turning it into fatty acids that actually nourish the cow. So the cow is not actually being nourished off the grass. It's being nourished off what the microbes in the rumen turn that grass into. It's just like what's happening out in the soil, but brought inside an organism, just like our colon is as well, as we'll get to a little bit. So if we look at the biological bazaar of the rumen, you're basically, food is coming in, there's all this microbial activity. It's basically a microbial ecosystem that is then supporting the cow. And how that functions has a great deal to do with the environmental impact of a cow, because what it eats affects very much what then comes out of the cow in terms of methane production. But the other part that I really want to emphasize tonight is looking at how the fat profile in animal products, in meat and dairy, is set by the diet of cows when we're looking at beef and dairy. So basically, there are two kinds of unsaturated fats that turn out to be critically important in modulating the human immune system: the omega-3 fats and the omega-6 fats. You've probably all heard about omega-3 fats. It's the stuff that's in salmon that we're supposed to eat so much of, right? It's good stuff. Omega-6 fats are also necessary for good health, but it turns out the balance between them is very different depending on what you're eating. And the same thing goes for cows, because cows can have very different diets. When they're out eating off the fat of the land, and they're eating mostly green living plants, they're getting a healthy dose of omega-3 fats. Why is that? Because omega-3s are involved in photosynthesis. So when you look at a green part of a plant, it's got omega-3s in it. What about omega-6s? They tend to be in seeds, because they tend to be, and seeds obviously have a very different purpose than leaves. Seeds are designed for storage, not for dynamic activity. Leaves are designed for photosynthesis. And when we feed when we feed cows different diets, they will integrate different levels of those omega-3 and omega-6 fats into their bodies, and that translates into the meat and the dairy that we then get when we eat them. So cattle that are actually out grazing on living plants and a diverse pasture forage, they will roughly have a balance of omega-3 and omega-6 fats. And if you look at the ancestral human diet, it had a rough balance of omega-3 and 6 fats. Most wild game has a rough balance of omega-3 and 6 fats. Why? Because they're eating the leafy green parts of plants. If you look at the diet of cows that are in feedlots, they're not eating leafy green plants. They tend to be eating seed-derived rations, things derived from corn, things derived from soybeans. They are rich in omega-6s. And what do I mean by rich in them? Well, about a 15 to 20 to 1 ratio of omega-6s to omega-3s is what you'll typically find in seeds, which ruined my image of corn chips, by the way, but that's a bad aside. But what it means for meat and dairy products is that if we're eating cows that mostly ate a diet of seed-derived things, we're getting bathed in omega-6 fats relative to omega-3 fats. Whereas if we're eating animals or dairy products that were grazed on living plants, we're eating a much healthier combination of omega-3s and 6s. And to be fair, you need both omega-3s and 6s to be healthy, for reasons I'll get into in a minute, but you want them kind of in balance. You don't necessarily need them to be so many omega-6s. So when we see seed oils in ultra-processed foods in our diet, those are awash in omega-6s because they're derived from seeds. So this all translates into the fat profile of our meat and dairy products. What our food ate actually influences what is in what we will then eat. And there's one other element to the difference in the diets of cattle that are eating a pasture versus concentrated diet. And Stephen Van Vliet and Fred Provenza put this out, I think it was last year or so, where they did a meta-study, a study of studies, where they reviewed 22 studies that compared animal products from animals that had a pastured diet versus a concentrate or a seed-derived diet. And they found very big differences in carotenoids, tocopherols, like vitamin E, polyphenols, terpenoids, phytochemicals that are known to have beneficial effects on human health. And the upshot is that in the animals that were grazing on a pasture rather than in a feedlot had anywhere from 2 to 20 times higher levels of these phytochemicals in their diet, in their bodies, in what would become our diet were we to eat them or their dairy products in the case of cows. So the way that we raise animals has a big impact on both the fat balance and the phytochemical content of the foods that we can get from them. I could talk a lot about the carbon impacts of livestock and animal agriculture as well, but suffice it to say that there's a lot more controversy over that than there should be over this. A pasture-raised diet, is basically a health plan for ruminants, why it's providing them with the things they need to stay healthy. How does this all then translate into human health and our diets? The last bit that I want to talk about. Well, when you think about public health over the last half century to century or so, there's been some really big changes. The graph on the left shows you the change in time from 1950 to 2000 of the incidence of infectious diseases, and you'll notice they're all going down. Until COVID, they all went down mostly. And that can be attributed to things like better sanitation, antibiotics, vaccines. I mean, the usual litany of the advances in public health that have so greatly impacted the global north. The graph on the right shows you over the same time period what happened to chronic diseases. They went through the roof. So we've basically had this giant switch in the nature of the things that are making us ill and taking us out, where our great-grandparents suffered from diseases that we hardly even recognize anymore. And most of us are suffering from one or more chronic disease that really weren't all that well recognized until fairly recently, and were nowhere near as prevalent as they've become in the last half century. And that's a big change. And the argument is that a lot of it is diet related, that many of these chronic diseases are diet related in terms of both what we're eating, which is the fairly well-known part, and the part that Ann and I are trying to argue for in addition, which is how our food is raised. 7 out of 10 of us in the U.S. suffer from one or more chronic diseases. That's a lot of people, and it's a huge burden on the public health system, and it's hugely costly. And a lot of it is related to what we eat and how we raise it. And a lot of those chronic diseases are rooted in inflammation. And inflammation is a process that you want to be active in your body. If you cut your finger in the kitchen on a knife, you want inflammation to start to become active and to take out the bacteria that are getting into your finger. But you want it to turn off when it's done. And chronic inflammation is the problem when inflammation doesn't turn off. And if we look at the relationship between inflammation and diet, there's been a lot of work in the last 15, 20 years in immunology that looks at the connection between certain types of fats in the human diet that maintain or terminate inflammation. And some of you can probably guess where I'm going with this. Because if we look at the mitigation of inflammation in time, you cut your finger, your onset inflammation, certain fats actually start inflammation, other fats are needed to end it. What are the ones that actually start inflammation? The omega-6s. What are the ones that quell inflammation? The omega-3s. So if you change from a diet where you have a rough parity, a balance of omega-6s and 3s, and instead you start eating a diet that has a 20-to-1 ratio of omega-6s to omega-3s, what do you think that does to your immune system? It's messing around with it. And the hypothesis is that can actually greatly influence the response to inflammation. But what that suggests is that maintaining a balance of these inflammation triggering and inflammation quelling fats are part of a person's natural health plan, part of the way our bodies are actually engineered to maintain good health. In terms of phytochemicals, phytochemicals are also known to play important roles in human health, and they play roles in communication, protection, and defense, those same 3 areas that phytochemicals play for plants. Phytochemicals serve those kind of purposes in us as well when they get into our diets. They'll often Many phytochemicals have anti-inflammatory properties or antioxidant properties that help serve some of those roles. And what do we mean by this? In terms of phytochemicals, there's actually thousands of different phytochemicals, and many of them are sourced in fruits and vegetables as sources, and they can also come through meat and dairy if our meat and dairy were eating plants that had enough phytochemicals in them. Those phytochemicals, they go down the hatch into our digestive tract, and our microbiome in our colon takes that organic matter, that food, and the phytochemicals within it, and they ferment them. And they ferment them into, basically microbial metabolites. They eat them. They then their waste products are microbial metabolites, but those microbial metabolites, if you go to the medical literature and look at what they actually do, many of them have anti-cancer properties, anti-diabetic properties, anti-inflammatory properties. They may help to maintain brain health, help to maintain cardiac health. In other words, those phytochemicals, if they're in our food so that our microbiome can process them and turn them into beneficial compounds for us, that's part of our health plan in terms if they're in what we eat. And it turns out that our agriculture, it seems, has been ratcheting down the amount in our quest to grow more calories. We've sought out means of agriculture that have depressed the quality of what's actually in those calories in terms of phytochemicals and healthy fats. So this is where Ann and I get to the Fab 4 here, where we, the farming practices profoundly influence the levels of micronutrients, phytochemicals, the balance of fats, and the amount of microbial metabolites in our food. Now, when we wrote What's Your Food Ate, we basically synthesized and read literally 1,000 peer-reviewed research papers to put the argument together behind all this. There's lots of data and evidence to support that farming practices affect each of these things. What we tend to hear about, though, when we hear about people arguing over whether farming practices affect the quality of our food, is that people argue over whether it's more nutritious or not, and whether organic farming and conventional farming are, which one is better. And it turns out, that if you look at the dirt book, you'll realize that organic farming can destroy the land. That's what the Romans did. That's what the Greeks did. They didn't have Monsanto. They didn't have Bayer. They didn't have agrochemicals. They had the plow. And that worked perfectly well to destroy their land. And if you look at many of the comparisons of just organic versus conventional farming in the nutritional literature, there's a lot of back and forth about whether there's any difference. But what we did is we parsed those studies. We read them, thought about them, figured out what they really could say. And it looks like the kinds of different things where people tend to see no difference on are the macronutrients. The basic chemical makeup of a tomato, for example. It's probably set by the genetics of the tomato. Not so much by its interaction with soil life, but whether it has mineral micronutrients and phytochemicals and microbial metabolites in it, that is set by farming practices. But these things, these Fab 4 that are up on the screen now, are not considered nutrients in the nutritional sciences. Why? Because you can live without them. You don't need them to survive. The question is, would you be able to better thrive with them? And I think the answer, based on the research we've put together in the book, is yes, very much so. How much so? That's an open question, in part because people have been focusing on asking the wrong questions. But these things all profoundly influence human health. You can go and look at individual studies of these things, and they can be related to things like preventing cancer, like maintaining brain health, and so on. But anyway, the basic bottom line message of this whole series of books, and particularly What's Your Food Ate, is that what's good for the land is good for us too, in very real ways that you can trace all the way around that circle that I've been going through tonight. So that's basically what I wanted to share with you. As a geologist, I never thought I would be writing about what our food ate. But the path, when you start looking into what makes for healthy soils and for sustaining healthy human civilizations and healthy individuals, you're kind of led to think about all these connections. And some of the basic ideas behind it are not new ideas, but the science behind it has been filling in and really supporting some ideas that were originally floated in the 1930s and 40s by some of the early pioneers of organic agriculture who didn't understand the science behind it all, but who had some pretty intuitive perceptions about what was going on. So I'll leave that there with you. If any of you want to pick up copies of these books, I've got copies of most of them over there. Feel free to come check them out. And if you want to ask questions, I'm happy to try and answer them.
Have you ever come across any studies involving high nitrogen fertilizers and the amount of nitrates that builds up in products that we eat and what that has affects our health. Because I worked in the container business and I know what high nitrate products do to a container. They're very corrosive.
Yeah. No, there are a few studies that have looked at that, and there's one of the things that's often found in comparisons of crops that are grown in low and high nitrogen environments are big differences in nitrates in the actual crops. There's been some concern expressed in the literature about the effects on human health. I haven't seen that much on terms of the direct connections. But yeah, there is some out there.
David, it's really eye-opening stuff. When is the medical and health community going to get behind the farm bill and put it all together?
That's a great question. I would like to know the answer to that. When I talk to my general practitioner about this, he's like, I never had any nutrition class. He's never been exposed to any of this kind of thinking. There's a huge gulf there. And I think as soon as we can start thinking about agricultural policy as public health policy through this lens, we would start thinking about farming really differently. And I think that the changing the what we eat and how it's grown are two of the biggest levers that we could pull to try and lower public health costs in the U.S. and literally around the world. But that's where, when I wrote Dirt, 15 years ago or so, I never thought I'd be writing about, agriculture as medical policy. But that's where the evidence really leads us. So I hope that the medical community and the nutritional community in particular, who I think have really been misguided in restricting their thinking to the stuff, to the classically defined nutrients as the stuff that we have to survive, which of course is important. That's the foundation, right? But if you're talking about survival, we can up the game and talk about health. And we seem to have prioritized growing large quantities of food for very noble reasons. You don't want anybody to starve. So provisioning lots of calories is important. But what's in those calories is the next level. So, I think we need to sort of retool our thinking from how to feed the world to how to nourish the world.
I have a question. Hey, we're over here. Yeah. Sorry. I wanted to ask to what extent these ideas apply to Africa, Asia, the farming practices you mentioned around the world just now. Mm-hmm. So I'm wondering, all of these chemicals that we add cost a lot of money, so I'm assuming they aren't as available elsewhere.
When I wrote Growing a Revolution, I visited farms in equatorial Africa, Central America, and across North America. And I did not write about farms in Asia because I ran out of money before I could get there. If you think of it in sort of there's multiple ways to degrade soil health, and you can do it without agrochemicals. And you can do it with agrochemicals even more effectively. So on the farms that I was in Africa, the big challenge there was that the farmers I was looking at were subsistence farmers. They didn't have money to buy patented seeds or to buy nitrogen fertilizer or to buy pesticides. What they needed to do, though, is to think differently about their soil to build the organic matter levels up so they could build the fertility up. And so that was involved in, to stop plowing. First of all, and then having polycultures in the soil so you had both diversity and continuous cover so you could build their soil quality back up. And it was very effective. And it completely contrasts with like the Gates Foundation, initiatives to increase fertilizer use in Africa. It's exactly the wrong way to go. And they've been talking that for a long time, and I've never been able to get through to them. So, the general principles of minimal disturbance, cover crops, and diversity apply independent of the technology level that you'd use to get there. But the general lessons, I think, apply relatively universally, but the actual methods you would use are very different depending on the context, the economic context, the climate that the farmers are in, the kind of soil they have. Like with the soils in the tropics, for example, it's really hard to ever get the soil organic matter up above 4 or 5% no matter what you do, because stuff just breaks down too fast. But if you can get it up to that level, it's really fertile. Yes?
In the last generation, more or less, there's been an explosion of gluten intolerance. Is that connected to what you're talking about? Because for some reason, I mean,
Yeah, that's a really good question that I don't have a really good answer to. But there's a couple things that are probably involved in it. One is crop breeding for high gluten content. I mean, that's happened in the last 50 years, so that the wheat, the people are getting more gluten today than they were getting before. That may have something to do with it. But there's also, much of our wheat is sprayed with glyphosate, a lot of it before harvest. And so there's questions in my mind about how much of the gluten intolerance is actually intolerance to the gluten, and how much of it is a side effect of intolerance to other things that are coming along with wheat. And then the reason for my suspicion on that is I've seen anecdotal accounts. I don't know of very good papers on this that are peer reviewed, so it's in the anecdotal world, of people who have gluten intolerance in the U.S. and then they go to Europe and they can eat all the bread and the wheat that they want there. If it's gluten intolerance, why the hell would that be? That's what's different is that they grow their wheat really differently in Europe, and they don't spray it with glyphosate. So I think that there may be a few things going on there, and I can't tell you which one really is the primary.
If you look at a loaf of bread in any supermarket, you'll find gluten is an added ingredient. And we've been adding gluten to common bread products for many years, and it's done to speed up the process.
Yeah.
Where European producers normally don't add gluten as we do here.
So that may be another piece of the Europe-U.S. difference. Like I said, I don't think I have a solid opinion on.
Did you do any comparisons with systems that with or without animals in it? Because there's this concern about eating lower on the food chain, and you've given a very good reason why animals can be an important part. How about those farms that did or did not have animals? Do you have any comparison of how they've worked?
Yeah, the slide that I showed you of Gabe Brown's farm with that really rich black soil, he had integrated both cows and chickens back into his rotation, so he had reintegrated animals. Some of the regenerative farms were using animal agriculture as well, but I don't have much. I got that one example. I don't have a lot of good comparisons. But there are studies that have looked at sort of carbon building in intensively rotationally grazed pastures that look like they're very positive benefits in terms of soil carbon. One of the interesting connections with cattle and animal agriculture that we did find comparisons in the literature for was that if you had cattle that were fed on a diverse pasture forage that had lots of phytochemicals, they tended to suppress the methanogens in the rumen that were producing the methane that's of such climate concern with cattle. I think that the jury's sort of still out in terms of the climate connection being, just how much it can be ameliorated with changing the way that we raise our animals. But the part that I think is pretty clear is that there's a lower carbon footprint for animals that are raised outside of a feedlot environment, and particularly if you take out. If you do overall comparisons of the environmental footprint of animal agriculture versus plant-based, the first thing I would ask is, well, how are the plants being raised? And that's never asked in those comparisons, because conventional comparisons, if it's destroying the soil, then how much better off is it? The jury, I think, is still out in terms of the net effects of those, but there's a very big argument going on about that now.
My favorite quote, it may be apocryphal, is supposedly an Indian in the West was on a hillside watching the farmer plowing the land, and he looked at it and shook his head and said, "Grass no good upside down."
Yeah. Yeah.
I'm just thinking about my grade school days in Northwest Ohio. My dad served a farming community there. And I just remember riding in the manure spreader, for example. And the mixed farming.
Yeah.
We had cows in different kinds of crops, and they rotated the crops, you know.
Yeah,
and
that
it was
kind
really
of
interesting.
in that kind of a setting, you can think of the cows essentially as an accelerant as think of them as an inoculant, where you're basically taking organic matter, partially breaking it down, and then mixing it with microbes, and then spraying it all at the back end of the cow all over the fields, or through the manure spreader, however one's doing it. But if cattle you treated that way on the land can actually accelerate soil building, there's it's been interesting. Then the whole history about why we divorced animal agriculture from cropping practices in the 40s is a really interesting exercise in I don't know, techno hubris in a way. It was done in the name of efficiency, and it turned out to be incredibly inefficient. At the level we're talking about, it's efficient for if you want to sell hamburgers. Any other questions? All right, well, if anybody wants to pick up a book, happy to sign them for folks. I appreciate your attention and the opportunity to come talk to you all again.
Shall we thank him so much for the...